Hi Year 4 and welcome back to your maths lessons. I hope you all had a really good half term and we are going to start our new topic. So the week before last I said that we are finishing fractions. We have finished our topic on fractions, however we're moving on to decimals now, but before we go into learning what decimals are and the value of decimals, we need to go over some more fractions. Okay, so I didn't lie when I said we're finishing it, because we have finished a topic on fractions, but it's important that we go over some fractions before we go into decimals. So today we're just going to be able to identify and compare tenths and hundreds. So those are the only fractions we're going to worry about today. So it should be quite straightforward. It's just kind of to ease our way back into it. Just so we have that understanding before we look into the decimals. So your star words today are fraction, decimal, hundredths, partition, and tenths. So let's go straight into it then. So how many columns can you see in this shape? What is this shape split into? How many equal parts? And hopefully you managed to count it, and it would be 10. So the shape has been split into 10 equal columns. So what is each column worth as a fraction then? So if this was like a fraction strip, what would each of these columns be worth as a fraction? So if it's split into 10 parts, each part would be worth 1/10. Yeah? So we have 1, and I'll write it out as well so you can actually see how you write it. Really hard to do joint up writing on a video. So we have 1/10, okay? How many would make a whole? So if it was a whole, you would have to count them all up. So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tenths would make a whole, okay? So it would look like that. So remember, whenever you have the same on the numerator as the denominator, then it's always going to be a whole. And in this case, 10 tenths would make a whole. And it says, how would you write this? So we've written it as a fraction, but if you're actually writing the letters as well, it would be 10 tenths, okay? Because these are tenths, okay? They're not tens, they're a tenth, okay? So 10 tenths. I'm really sorry about my handwriting. It's really hard using a mouse to do it. 10 tenths. That's how we would write it. Now let's look at this. So how many squares can you see now? Now, rather than counting them all individually, you could just use it like an array. So count how many are down the side, how many are along the top, and then times them together. So you should see that we have 3, 4, 5, 6, 7, 8, 9, 10. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 10 lots of 10 is 100. So what is each square worth as a fraction then? If in this, each one was worth a tenth because there were 10 columns, what is each square worth here if there are 100 squares? It would actually be 100th. Okay, so who wants to do it? So each of these squares is worth 100th, and you write that, so 100th. Oh no, I've missed out the T. There we go. So 100th. A bit of a tricky word to say. So how many hundredths would make a whole based on this? So that would mean that all of them were shaded in. How many of them would need to be shaded to mean that the whole shape was shaded? And it would be 100. So 100 100ths would make a whole. Okay, so that looks like a 6. There we go. So hopefully that's all quite straightforward so far. That's just using our knowledge that we've already learned on fractions just to look at tenths and hundreds. And it's just getting ourselves used to using that vocabulary, because they're not tens, they're tenths. And these are not hundredths, they're hundredths. It's quite tricky to get your head around, but this is how you spell them, and that's what each part is worth. So what about this now? So we have one of the shaded boxes in. How many are shaded? How do we know? How would we write this? So we've already covered that because we looked at what one box was worth. So we know one box is worth 100th. Wants to let me do it. There we go. Because there are 100 boxes. And we write that like that, or we would spell it out like this. But then it says, what fraction is unshaded? Now, if you know that there are 100 boxes there altogether, one is shaded, you would just take one away from 100 to work out how many are unshaded. So it'd be 100 take away 1, which is 99. Okay, so therefore 99/100ths are unshaded. Okay, and that's just because I've taken, think of when we were taking away fractions, if a whole is 100/100ths and you take away 1/100th, that's going to equal 99/100ths. Okay, so hopefully that makes sense so far. What about this then? What fraction is this, and how do we write this? So let's look at the first one, where we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 equal columns. So therefore, what fraction is this going to be? If you have someone there to talk to, or you want to pause the video to have a go yourself, then do so. So hopefully you managed to have a think about this, and this would be 1/10, okay, because they're split up into groups of 10, and therefore this is 1/10 shaded. If two of them were shaded, it would be 2/10, 3, 3/10, 4, 4/10, and so on. This one then, what fraction is this? So this is 100 square again, so we've got 100 squares. So each one of these boxes would be worth 1/100th, okay? Now, if you counted all of these, there would be 10. So therefore it's 10/100ths, okay? Now, is there a link, just by looking at the picture, not the fractions, between this shape and how much is shaded? So hopefully you'll be able to see that there is actually a link, because it's the same amount that has been shaded. So this shape has just been split into tenths, this shape has been split into hundredths, and the same amount is shaded. So therefore 1/10, because that's what that equals, is the same as 10/10, because that is what that equals. So they're the same, and you can see that because it's the same amount shaded in each shape. They're just split into smaller boxes on this one. So 1/10 is the same or equivalent as 10/100ths. So now it's your turn. I want you to work out what fraction is this, how do we write that, and then what fraction is this, how do you know, and is there a link between these two? I can't zoom it out, so I'm going to have to, if you want to pause it to do the first one, then I'll scroll down for you to do the second one. So that's the first one, and then that's the second one. If you're not sure, then we'll go through the answers now. So we know that this is split into columns of 10, so each part is worth 1/10. So if that's 1/10, we just count how many are shaded. 1, 2, 3, 4. So therefore it's 4/10. So imagine these are all tenths, and you add them all up, 1, 2, 3, 4. That's just going to equal 4/10. And if you're writing it, it would be not 10/10, sorry. I wasn't concentrating then. It would be 4/10, like that. Then the next one, what fraction is this? So this one, there are 100 squares, and we can see that there are 10 in each column, and there's 1, 2, 3, 4. So there's going to be 40 shaded. You might have counted them, but that would have taken quite a while. But I know because there's 10 in one, if this is 10, that's 10, that's 10, that's 10. Just count in tens, 10, 20, 30, 40 to add them up. So therefore it's 40. And then what is each box worth? 40, what do you think? Hundredths, okay? And we would write that as 40 hundredths. Oh. There we go. And again, there is a link because you can see the same amount has been shaded as it has been here. So therefore 4/10 is the same as 40 hundredths. And you might have used your previous fraction knowledge to actually work out that you could simplify this down to that. If you divided both of these by 10, If you divide 40 by 10, you'd get 4. If you divide 100 by 10, you'd get 10. So without even looking at this, you would be able to know that these are equivalent because you've already done that. You've simplified fractions in the previous term. Moving on then to this, we're nearly done. Sorry, I know I'm going on quite a lot today. We're going to look at partitioning now. So how could we break this up into tenths and hundreds? So if we have 56 100s, let me just pause the video and shade that into this. Okay, so all I've done is shaded in 50 because I can see it's 56, and think about it if it was just 56 without being 56 hundredths, you would know that to partition it, 56, you just partition it into tens and ones. That's what partitioning means. So you've got 5 tens, which is 50, and 6 ones, which is 6. So therefore, 56 just on its own, if you partition that, it would be 50 add 6. So it's the same concept, even though we're looking at hundredths. So all I've done is shaded in 50 hundredths, okay? Because that's how many tenths, I guess, there are. So it would be 50 hundredths, which is what I've shaded, and then you've got 6 hundredths less, which I'll do in a different colour. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There we go. 6. So you can see that I've just partitioned that into tens. It's like how many full block of tens can you make, which is 5, 50. So 50 100, and then you've got 1, 2, 3, 4, 5, 6 hundredths left. Okay, so it's the same concept as what you do here. You're basically just adding the hundredths part to it as well because we're looking at hundredths. So this part would be 600. So 56 hundredths can be partitioned into 50 hundredths, add 6 hundredths, and if you added them together, you would get this. Hopefully that makes sense. It's just another way of showing it, and it's the same process as what we've done before when you just partition a whole number, but we're just looking at a fraction now. So now it's your turn. Can you partition this for me? So can you break it up into how many full blocks of 10 you would be able to make, and then how many are left over for the second part? If you're not sure, we'll go through it now, and I'll just pause the video so we can, so I can quickly do it on here for you. Okay, so all I've done is shaded in 20 100ths because I know that there are 2 10s. So that's 1 10, that's 2 10s. So that is 20 100ths. So that's the first part of the part whole model. So 20 100ths, and then how many are left over? How many more do I need to shade in to make 24 100ths? If I've already done 20 and I need to do 24, how many more would that be? 4. Okay, so if you count those all up, that would be 24 hundredths, and you can see that it's 20 hundredths add 1, 2, 3, 4 hundredths. So that would be 4 hundredths. Okay, hopefully that all makes sense. Now it's your turn to have a go. So group 1, if you're not feeling too sure about this, and have a go at this first. This is only on here, I'm afraid. I haven't got it on a PDF, so you'll just have to copy it off the screen. You don't need to draw or anything. You can just write the answer in your book or down on a piece of paper. Pause the video to have a go at this one. And then this is the second part for group 1. And then some questions for group 1 as well. Now this is on the PDF on the website if you did want to print this out. This is group 2's question. And the second question. And then there is a challenge. So once you've had a go at some of those questions, come back and we shall go through the answers. Okay, welcome back. Let's go through the answers then. So group 1, how many tenths are shaded? So I actually told you what fraction each one is. So each of these blocks is worth a tenth. So you just had to count how many are shaded. So 1, 2, 3, 4, 5, 6. So this is 6 tenths shaded. This one is 1, 2, 3, 4, 5, 6, 7, 8. 8 tenths shaded, and this one is 1, 2 tenths shaded. The last one was a bit different because it was split into hundredths. However, actually, if you know that this is worth 1 tenth, because that is, if you added them all up, it would make a 10. It would be 1, 2, 3, 4 tenths. which is also the same as 40 hundredths. So if you wrote 40 hundredths, you're still correct. However, the question was, can you write it in, or how many tenths are shaded? And there's actually 4 tenths. Just because you know that this is 1/10 because it's added up to make 10, 2, 3, 4. Okay. So hopefully you managed to work that one out. So now this one then, how many hundredths are shaded? This one, it would be 1, 2, 3, 4, 5, 50 100ths. This one is 20, 1, 2, 3, 4, 24 100ths. And this one is 1, 2, 3, 4, 5, 6, 60, 1, 2, 3, 4, 5, 6, 7, 8. 68 100ths. So hopefully that was all quite straightforward for you. Third part for group 1 then. What fraction of each grid is shaded? So there are 9 tenths shaded because there's 9 rows of 10 shaded. This one, 3 tenths are shaded, so it would be 3 tenths. Then hundredths, so here it's 83, I think. So 83 hundredths are shaded. And this one is 1, 2, 3, 4, 5, 6, 61, 2, 3, 4, 5, 65 hundredths shaded. And then this one, 1, 2, 3, 4, 5, 6, 7, 7 tenths are shaded. Group 2, Andy says that 96 hundredths of the grid is shaded. Bella says that 9 tenths add 6 hundredths of the grid is shaded. Emma says that 8 tenths add 16 hundredths of the grid is shaded. Explain why they are all correct. So the first one's correct. Andy is correct because you can clearly see that if each of these are a hundredth, there's 96 shaded. So therefore 96 hundredths are shaded. Bella is correct because 9 tenths is the same as 90 100ths. So all she's done is seen that this is 1/10. I should use another pen. That's 1/10. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths shaded, and then 1, 2, 3, 4, 5, 6 hundredths. So she's just converted it into tenths as well as hundredths. So she's partitioned it basically into 90 100ths add 6 100ths, but then simplified 90 hundredths down to 9 tenths. So hopefully that makes sense. And then Emma says that 8 tenths add 16 100ths of the grid is shaded. So she has partitioned it as well. So again, she's counted them as tenths, or she's added them as hundredths and then simplified it down. And actually, if you had 8 tenths, let me just rub that out. If you had 8 tenths, that would be 1, 2, 3, 4, 5, 6, 7, 8. So all of this would be 8 tenths because each row is a tenth. So 8 tenths. And then if you count from there how many hundreds there are individually, it would be 16 because you have 10 100ths add 6, which is 16. So she's just partitioned it. You could have so you could have 7 tenths add 16 100ths. That would still be right. It's just a different way of writing. Sorry, it would be 26 hundredths. You could have 6 tenths add 36 hundredths. You can partition it in any way as long as it adds to make the same value of 96 hundredths, then it's still correct. So the second part for group 2 then, it says work out the total shaded area of each diagram. So this one, there's 1, 2, 3, 4 rows of tenths shaded, so 4 tenths, and 1, 2, 3, 4, 5 hundredths. And that would be 4 tenths add 5 hundredths equals 45 hundredths. So if you're writing it here, you would just write in the values. 4 tenths add 5 hundredths. Sorry, it's really hard to write it in, which is 45 hundredths. That was an 8, sorry. This one, there's 1, 2, 3, 4, 5, 6 tenths, and 1, 2, 3 hundredths. So 6 tenths add 3 hundredths is 63 hundredths. So then in there would be 6 tenths, there would be 3 hundredths, or vice versa, and then that would be there, rather than me squeezing it in. And the last one then, the challenge says who is correct? So Dora says 5 hundredths is equivalent to 50 tenths. So she is saying that 5 hundredths is equivalent, the same as 50 tenths. And Amir is saying that 50 hundredths is equivalent to 5 tenths. So Amir is saying 50 hundredths is equivalent to 5 tenths. So who is correct? Now, straight away I can see that Amir is correct, because actually if you simplified this, if you divided both of these by 10, you would get that. So therefore it must be the same. So if you do 50 divided by 10, which is 5, and then 100 divided by 10, which is 10, it would be 5 tenths. And again, if you drew a grid to work that out as well, you would have, if you drew a 100 grid, you would have 5 rows of tenths coloured in, and that's also 50 hundredths coloured in, if that makes sense. Dora is incorrect, because actually 5 hundredths, so that would be 5 squares coloured in on a 100 grid, is not the same as 50 tenths. 50 tenths would be, because that's an improper fraction, the top number is larger than the bottom number, so it's it would be over the whole value anyway, so it isn't correct. You don't need to really know why, but for now anyway, but this one is the correct one because you can simplify it as well. That's everything for today. Hopefully that was all okay for you, and was a relatively easy way to get ourselves back into it. Sorry for the really long video, but thank you for watching.